Hello, I am Lama Bahanan from the Georgia Institute of Technology, and I will be presenting to you my work during the REST program. About 86% of battlefield deaths happen within the first 30 minutes of trauma. This makes speed and accuracy the most important factors for trauma management. But in combat zones, due to the hostile environment, a soldier can be left for more than 72 hours without medical care, which increases the mortality rate. And this could be for a variety of reasons, such as the limited availability of medical equipment and personnel. So, for example, you might have the equipment for a procedure, but no one with the skills to do it, and vice versa. And one of the critical life saving interventions for managing trauma is femoral vascular access. It is the most common method for obtaining central venous access. Also, it's a prerequisite for more advanced resuscitative methods. And this type of access is hard to conduct even for skilled clinical personnel. So imagine how much harder it would be to perform in a battlefield environment where one may experience a high degree of mental and physical stress. So, if we think about a solution for resolving this problem, I'm pretty sure that automation might be the first thing that pops up for many of you. And indeed, it was the first thing for us as well. Our team has been working on developing a handheld, robotically assisted femoral vascular access device so we can remove the reliance on human factors such as operators' experience and possibly reduce the cognitive load. And although there has been a substantial effort in developing robotic surgery technologies for vascular access, none of these systems are suitable for femoral vascular access due to the unique anatomy of the femoral region. But our team was able to do a lot of technological advancement for developing such a system. But there was a need for a parallel study into the user requirements for steering the hardware and software features to match the expectations of our targeted users, because eventually we want our user experience to be as good as our technology. And to do that, we utilized a user centered approach, which is widely used for developing medical technologies and has been proven to improve efficiency, consumer approval, and usability. Moving to the methods, based on the extensive literature review, we modified the current device using SolidWorks and developed a mock-up GUI using MATLAB that we later presented during our user interviews with medical personnel with civilian and military experience. Then we categorized the user input into hardware and software requirements. There are four major hardware requirements: minimum size and weight, and maximum power, which are crucial for any portable military device. Another important criteria was stability. Since we are aiming for a handheld device, it's necessary to ensure that our design decisions offer maximum stability and control. As for the software, because we want to enable non-skilled operators to perform this type of access, the user behaviors become a highly important aspect. Thereby, for developing a workflow for the graphical user interface, we utilize the design with intent approach. This approach is used to influence the user's behavior to a targeted one by using suggestion tools throughout the procedure. In the future, we plan to conduct more interviews as it was one of our main limitations in the study. This will enable us to generate more specific functional and non-functional requirements. In the end, I would like to thank Rachel Berson, Dr. John Dolan, my mentors and sponsors for offering me this opportunity.